So we have finally reached the last section in the first module. We'll explore the data scientist toolbox. It's important to know what kind of tools are available for which eases the life of a data scientist while he's trying to deal with data. So what tools do you use for manipulating data, engineering data, visualizing data, creating algorithms, or probably you want to put into production a machine learning algorithm? What kind of tools and infrastructure is available? A lot of questions, right? So we'll actually take a shot at understanding what does the market offer at the present, and then what languages we'll be using in this course, and why do we use them. So towards the right hand side, this is a list of a couple of popular languages available in the market right now. R and Python are the most popular ones. We have SAS, SPSS, Julia also coming up. And Excel is a tool which actually fits in anywhere. It's extremely useful for doing quick and dirty analysis. You want to showcase or present some results to somebody else, create quick mock-ups of dashboards. Excel is probably a tool which fits in everywhere. The only trade-off over here is it's difficult to work with large amounts of data. So what we and one thing I wanted to point out. So today R and Python are really popular, but then a couple of years back, I would say SAS was one of the most popular languages. Today it's getting a little obsolete because R and Python are offering free alternatives than SAS. SAS was very expensive. The licensing system for SAS was very expensive. And today only I think it's mainly popular across the banking domains. Most of the banking companies still prefer SAS. There are definitely a couple of others, but then mostly you'll see the banking companies are the ones who still use SAS. Most of the industry have actually transitioned towards R or Python, and now in fact towards Python. So in this section we'll be using Python. Like this entire course we'll be having the entire hands-on activity with Python. Let's take a look at understanding like why are R and Python very popular. So a little background about R. So definition wise, R is an open source programming language and software environment for statistical computing. It's widely used by researchers and data miners. It's actually an implementation of S language. It was created by a team from Bell Labs. So S stood for statistics. It is a language which actually offered uh, most of the important algorithms and statistical techniques for researchers, academicians, and all of those PhD guys who wanted to do data analysis at a small level. It actually offered a lot of things compared to the time it was developed in. Later, a couple of folks from New Zealand in University of Auckland launched the first version in 1995, and a stable version was actually released in 2000. So the name R actually came into picture because both of the founders, Ross Ahenka and Robert Gentleman, both of their names start with R. The language, but actually got a lot of traction somewhere around the year 2005. So a scientist named Hadley Wickham was largely responsible for this revolution. He actually launched various packages that made life very easy with R. So a lot of packages around visualizing data and manipulating data is actually made possible with the packages launched by Hadley Wickham. It started with 2005 where he launched the package Reshape. Reshape was what we do in so the pivoting process in Excel is actually what we do in Reshape. So it made the process of pivoting data across dimensions extremely simple. So today, almost all libraries launched by Hadley Wickham are extremely popular and downloaded a million number of times. So almost the entire community of data science using our leverage package called DPLYR for data manipulation. It makes the entire process very easy. Almost everyone visualizes data using a package called ggplot. Pivoting data is completely done using the package Reshape. There's a newer version called Reshape 2, and so on. So the language got extremely popular in 2005 and got a lot of traction because it is very easy to use, and a wide and a large community was actually supporting the language. So it was very easy to get help, and then there's no better alternative at that point of time. So from 2005 onwards, R really picked up. Somewhere around the same time, Python also started picking up for data science. Like Python was also in the picture from 1991, but then it actually got traction after R's popularity. So let's take a look at Python. Python is also a very popular open source general purpose programming language. It was created around the year 1991, and majority of the data science components actually came around the year 2005. So once R started getting popularity, Python also had a community which was ready to adopt data science into their stack. So a lot of packages were developed which actually provided data science features, and they actually mimicked a lot of features right away from R. The revolution happened somewhere around 2009. 2009 was the time when Pandas was launched. So just to give you a brief context of what Pandas, so in R, the easiest way was the easy task of manipulating data was actually provided by data frames. Like it's something very similar to what you have in Excel. You have a tabular data format data. You can actually do row-wise operations, column-wise operations, and much more in using a couple of functions. So that entire process of visualizing data as a data frame in R was mimicked in Python using Pandas. Similarly, NumPy was a set of functions that helped us do a lot of operations on an array. So you needed some array level operations. It was very easy using NumPy. Matplotlib was the visualization library, so something similar to ggplot in R. Matplotlib offered Python speed a couple of functions that could be used for visualizing the data. SciPy was a collection of statistical techniques, which was very similar to what we had in MATLAB. And another breakthrough happened with scikit-learn. Scikit-learn is actually the machine learning uh, package for Python. It's an extremely exhaustive and well organized package which actually covers the end, almost all the important techniques in machine learning under one roof. So a combination of all of this actually made Python a great option to explore for data science. Now, the other edge Python had was Python was more object oriented and there was a less steep learning curve compared to R. So today, if you look at the data science community, significant portion actually comes from computer science background, and computer science background guys will definitely have some sort of exposure to languages like C++ or Java. So with someone with exposure to these languages, for them to pick up Python is relatively very simple than to pick up R. So it offered a lot of other options, other advantages also. So since Python was very popular for a lot of different software activities, it is very easy to take any machine learning model into a production code. So the production level support, almost the entire stack of software in the production environment had great support for Python. So that naturally made Python a preferred choice for computer engineers. So it's easy. So you can actually start from scratch, manipulate data, work with data, engineer data, visualize, create algorithms, and then finally put them into production using Python. And there's a lot of support for Python in the production environment. R on that front might be a little lower. So today, if you look into the market, we can say R is actually a language mainly used for prototyping, quick and fast prototyping. And when you actually take a machine learning model or a final product into production, Python is kind of the preferred choice. Moreover, deep learning is picking up really well in the market, and Python has a lot to offer on the front of deep learning. R also has it, but the kind of packages or different frameworks which which have been launched, Python has been a clear winner in this case. So sometime down the line, so right now we would say the community is equally divided across R and Python, but then sometime down the line I can see Python becoming a clear winner. In this course, the entire hands-on activity, including learning basic program constructs and how to handle data, building models, all of that hands-on activity will actually be covered using Python. So that's a brief introduction to the topic and the data scientist toolbox. In the next section, we'll actually explore the data scientist toolbox in more depth. So we'll actually get started with Python and understand how can we use Python to play around with data. We'll learn how to set up and install Python and get started with the language. So at the end of module 2, you'll have a pretty good exposure, hands-on exposure to Python. and you'll have basic understanding. So you already have basic understanding about data science and machine learning. Module 2, you'll have a basic understanding and good hands-on activity of Python, which will make us ready to get started to the main core algorithms. So that's it for now. Thank you for being so patient. Looking forward to meet you in module 2. Thank you so much.